Hello everybody, welcome to the cybersecurity project video tutorial. Today I will show you something about a very powerful tool named as Fragroute. The Fragroute have two main functions. One is frag test and the other is Fragroute. In the next 30 minutes, we will first show you about the frag test and then introduce some basic modules in the Fragroute. The last part of our video tutorial is quite amazing. I will show you how to invade the ideas using the Fragroute.
In this part, I will introduce the frag test, which is a very useful tool embedded in the Fragroute. It is used to test IP fragment reassembly behavior in the attacks. Now the first one is ping. Ping is used to send an ICMP echo request to the host. And now it comes the IP trace cert. It determines the path to the target. The third one of the frag test is IPOPT, which is used to send an ICMP echo request with different IP options to see which IP options are supported. Now here comes the Fragroute. Fragroute is used to try 8-byte forward overlapping IP fragments favoring new data. And as for the Fragroute, it tries 8-byte forward overlapping IP fragments favoring old data. Now this is for the frag timeout. It determines the IP fragment reassembly timeout and wait for an ICMP time exceeded in reassembly reply. And here you can see the timeout is about 29 seconds. Now the last function is frag test all, which include all the functions in the frag test. Frag test is a very useful tool which probes the remote host to determine its TCP/IP stack behavior.
So after the introduction of the frag test, we will show you guys about how to run Fragroute with the default configurations. Every time before we start the Fragroute, we should make sure that the root record is clean. And before we start, we should manually ping the host IP address to add the record to the root. So with the command ARP, we could see whether or not the IP address is added to the record. And then we use the Fragroute command and with the default configurations. This time we use netcat tool to transmit some packet from the Kali to the operating machine. You could type in any words in this terminal, and by using the netcat tools, it will transmit to the operating machine. Theoretically, all those words should be in one TCP packet because the length of this word is not exceeded the limited. But actually, we could use Wireshark to sniff in those packets. We found that there are so many packets here, at least 100 times, and some of them is in wrong order, and some of them maybe lack of information, and some of them is retransmitted. So that's how the Fragroute is working. He just do some manipulations of the packet. And if you turn back to the Fragroute terminal, you could see the record that the Fragroute do something for those packets. It's so many record here, but one record is one packet in this Wireshark. It's one by one. And now I have shown you how to use the Fragroute. After that, I will show you how to close the Fragroute. We could shut down the Fragroute by Ctrl+D and kill the process of the Fragroute, depending on the PID. And the default configuration file is located at the /etc/ and those configuration include some basic modules. It's TCP segment, ipfrag, ipchef, and other. All those modules we will talk about later, and after those default configuration tests, I will show you some basic modules. Oh, don't forget to delete the road record. After showing how to use the Fragroute with the default FF configuration, I will now show you some basic modules in this tool. The first module is the TCP segment module. Just follow the way we use in the default configuration. Now let's just firstly ping the host IP address. And we'll to check whether or not those records has added into the route. Now it's successfully added, and then it will come some differences here. In testing the modules, we should create the configuration file by ourselves. We could random those names, but be careful. Those files should be .conf. The format of the TCP SEG is quite simple. Just the TCP SEG follows some numbers. The number must be the multiple of 8. If it's not multiple of 8, it will cause some errors. Just save and out. We could have our fragtest.configuration for the module testing. Theoretically, using this module, every packet will have the limit TCP data length. In this configuration, we set the length as 8, so every packet would have the TCP data length as 8, except the last one. So let's prove it. Then is to run the Fragroute just as the same as before. Be careful the host IP address. Now the Fragroute is running. And then is to open the connection between those two machines. In our video tutorial, we will use Netcat as transmitting tools. Just making the connection between those computers using port number 15,000. Now the connection has been built. The next step is transmit some data. To see how the packet now is, we should use the Wireshark to capture all those packets. So let's restart the Wireshark. In the Kali terminal, let's type some random words. It's all random words, and send it to the operating machine. We could see that those data has successfully transmitted. And inside the Wireshark, we could see that the original one packet now is 5. And for every packet, its data is 8 bytes. And combine all those 5 data, we could combine the stream that's what we typed in the terminal. So that's how the TCP segment modules work. And we will show you some other modules in the next. The second module we will introduce is the order module. In this test, we will also use the TCP segment module. The format is quite simple, just order, space, random, or reverse. You could pick one of these options, and we could save and quit. This time we use order reverse. After creating the configuration file, we just let the Fragroute run. First, they ping the host IP address and Fragroute the configuration file and the host IP address. Then let's make the connections. The Netcat tool is quite famous in our test. I use hundreds of times here. Okay, connection is built. Let's transmit the data between those two computers. What I type is just let's transmit something to the META with the model order. The transmission is successful and the Fragroute is working, and see the Wireshark. Oh, I forgot to activate the Wireshark sniffing, so let's transmit again. The same word, let's transmit something to the META with the module order. So at this time, the Wireshark has captured the packet In reverse order, we could see at the TCP data part, just a reverse order of those words that have tapping. That's how order module is working. The next model we will introduce is the delay model. We start from delete the formal Fragroute setting. Then we could create a new configure files. In test this model, we could use the TCP sec module and the delay model. The format of delay model is quite simple. It's just delay, space first or last or random, followed by some numbers. You could delay 100 milliseconds as we do in this test. After we have this configure file, we could start the Fragroute. And we could see that the delay model has activated. Then we could make the connection between those two computers. Type in some random word for transmitting. In this part, don't forget to restart the Wireshark sniffing because I guess we forget to start it. So let's do it again. The same word transmitted successfully, and let's see the result in the Wireshark. Now we could see those packets. The last one is in red. That's my friend's fingers. This packet is delayed, and we could see the data it have. It should be the first data in order that we have. So now we could also see the flag that confirms that the packet is delayed. So that's how the delay model works. The next module we will introduce is the IP check module. The basic role of the IP check module is to retransmit the packet with delivery different payload and different TTL values. IP check is a very complete module. It includes 3 options, and the first one is the dupe option. So we just change the configuration file, use the dupe option. Theoretically, by using this option, the Fragroute will retransmit the packet with the same IP information but with the random payload. So let's prove it. In Kelly's terminal, random type some word to transmit, so we could do the Wireshark sniffing depending on the Fragroute. So every packet has been retransmitted with a different payload. So that's IP-chef OPT work. Oh, sorry, that's how the IP-chef dupe work. The second option is IP-chef OPT. We close the Fragroute, restart the Wireshark, and change the configuration file. The format of IP-chef OPT is similar to IP-chef DOP, just followed by some OPT or DOP of the IP-chef. After changing the configuration file, we start the Fragroute. And don't forget to clear the Wireshark sniffing, because in my test I forget. So you will see me just restart the Wireshark and retransmit those data. This time you could see that there are some late delivery of those packets. And also there are some different payload in this. So this is how the OPT works. And the last option is TTL. In chef TTL, we could change the TTL value of the packet, but in still, those packets are not the first one we transmitted. The first one we transmitted is the original one with the right TTL value. What we change is the retransmit one. Let's prove it of the experiment. The format of IP-chef TTL is some different because we need to add some values of the TTL. Or we could not try any TTL value, so the default value will be 1. Still, we could type some word in this netcat, and don't forget to restart the Wiresharks. Okay, in the Wireshark, we could see that the TTL is 0 because we set the default value. So that's how the IP-chef module works. The last module I will introduce is the TTL module. Let's firstly create the configure file and the IP, TTL, and the number. And then we ping this host IP address to activate the Fragroute. Now the Fragroute is running, and then let's just restart the Wireshark to see the new packet. Type in the word you want to transmit and to see the differences here. We could see that the TTL value now is 20, just the value that we set in the Fragroute configuration. So every time we set the TTL value, we could change the TTL value in this packet. So that's how this module works. The last part of our video tutorial is about how to use Fragroute to check the snot. So this time, the first step is to run the snot in the operating machine. This is how to change the default setting of the snot to make it work. We just uncommon and common some setting. Those two settings are at the very beginning of this configuration file. Then, as we want to simulate the real-world situations, we will create a new rows and add these new rows to the snot configuration file. We just solid create the rows named as my.rules. Then we shall type in some rows. To make this project simple, we do not make much limitation there. We just let the rows triggered by some basic content PASSWD. The other part is not important, and the message is our Fragroute rules, and the SID is 1000000 and 1. And save this rule. Now we shall add this row to the configuration file. I will show you how to find the places that we could include a new rows. Just page down, 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 and you could find, yeah, not yet. Okay, here. Now we could add our new rows here. Just follow the format. Include row page slash my.rules. After doing that, save and out. The next step is just open the connection between this Kelly and the meta, just as we do thousands of times before. After the port open, we should use the sudo command of the snot to let the snot working. Be careful of the command snot and the directory of your current location to make sure that your commander is right and just like ours. So now means your snot is running. Now we change screen to the Kelly. We should build the connection, just like handshake. Just NC, host IP address, and port number. And we send the text file here. It's a test for password keyword sort of things. This time we do not use Fragroute, so basically the snot must respond for those keywords. Let's see. Alright, the snot has successfully captured some packet. And just quit the snot and to see the log file. Let's get the alert. We could see the warning here, just our rows. So that means that the snot has successfully captured the dangerous packet, depending on the rows. Now we just remove the alert to restart the netcat and restart the Fragroute to make the process again. But the difference is at this time we shall running the Fragroute. Delete the netcat process is a bunch of things, but we must do this. Now the snot is running again, and let's do the Fragroute things. This time we create a brand new Fragroute configurations to cheat this knot. And we try hundreds of times, maybe too much, but a couple of times to see how can we use the module to cheat this knot. And we found that the TCP segment could play a very good role here. And we set as TCP segment 4, and then we let the Fragroute running. Don't forget to open your Wireshark and see the packet here. The connection is now on, and we send a test for my keyword password here. So in the meta, we still capture some packet, but the length of the TCP data is 4. And let's see the log file alert. Similar, we sudo cat alert, but this time, nothing. No alert here. So what that mean? I guess that means that this time the snot has not found the keyword password PASSWD. So in this way, I guess the Fragroute has helped the netcat avoid being detected by the snot. Generally, Fragroute can not only cheat the snot but also other IDS, but as a technology has developed for all those 10 years, some simple modules will not be still useful, but except the TCP segment 1, but TCP segment cannot be used in some ways because of the network traffic or network settings. But anyway, Fragroute is still a very powerful tool in invention, although the author of the tools want to people use it in a good way. So thank you for watching our video tutorial about the Fragroute.